Okay, in this lesson, we're going to find the linear equation from looking at a data table. Okay, we've done it from the graph. We found an equation after looking at a graph, but now we're going to look at the data table. And I want to show you the relationship between a graph that I have on the left to the data table that I have on the right. Okay, let's just look at this line for just a minute, the graph. Okay, the slope up 1 over 2. Up 1 over 2, up 1 over 2. Okay, so the slope is 1/2. Okay, the y-intercept is 3, because that's where it crosses the y-axis. But I want you to see how the graph corresponds to this data table. Okay, look what I did. I'm just looking at points 0, 3, 2, 4, 4, 5, and 6, 6 are just some of the points on my graph. I just put them over here in the data table. 0, 3, 2, 4, 4, 5, 6, 6. Okay, the trick is, notice the relationship here. When I'm finding the slope between the first 2 points, okay, I'm going up 1 space over 2 spaces. But look at this. Use a different color to keep it straight. Okay, when I rise 1, notice I'm going from 3 to 4. See, that's my rise of 1. Okay, going from 3 to 4, I'm going up 1. And that's the same as the y-coordinates of those 2 points. So when I rise 1, I'm going from 3 to 4. Look over here on the data table. My rise is the same as going from 3 to 4 on my y values. Okay, my run. Okay, when I run 2, I'm going from 0 to 2. And now look at the x coordinates, 0, 2. Okay, so when I run 2, I'm going from 0 to 2 on my x coordinates. So on my data table, my x values are going up by 2. Okay, so take a look at the next 2 points. Okay, from my 0, 3 to 2, 4, my y values went up 1 as my x values went up 2. Okay, to go from 0.24 to 4, 5. Okay, to get from 4 to 5, my x values are going up 1. And from 2 to 4, my x values are going up 2. So the rise is the change in y, and the run is the change in x. Here we go again, 5 to 6. Y's are going up 1. The x values, the x's are going up 2. So the big idea is that the slope of a data table, instead of doing rise over run, we're going to say it's the change in y values over the change in x values. Okay, because the change in y values is really the rise. Okay, the change in the x values is really the run. So change in y over change in x. Okay, the next thing, the y-intercept is the other part of an equation that we're interested in. Think about the y-intercept of 3. Think about any y-intercept. Okay, a y-intercept is a point that's crossing the y-axis. Okay, think about this point. Okay, this point right there, that's 0.05. So that could have been a y-intercept of a different problem. This y-intercept above that would be 0.6. 0.7. Okay, what do you notice about any any coordinate that's sitting on the y-axis? 0.7, 0.6, 0.5, 0.3. Okay, the x-coordinate is always 0. So to find the y-intercept from a data table, you want to find the y value that's across from x equals 0. So the y-intercept of a data table is the y value that corresponds, I'll just put across from, an x value of 0. Okay, so slope of a data table is change in y over change in x. The y-intercept of a data table is the y value across from x equals 0. Let's look at an example. Okay, so here's a data table. I want to know an equation that represents this data table. Okay, first thing I'm going to do is I want to find my slope. Okay, my slope is my change in y values over the change in x values. Okay, let's look at the y values. 20 to 18. Okay, do you notice that that's going down to? 18 to 16. 18 to 16, that's going down to. 16 to 14, that's going down too. My change in y is a decrease of 2. So it's negative. Okay, my x change, just go down the x side, the left side of the data table. 2 to 3, that increases by 1. 3 to 4, that increases by 1. 4 to 5, it increases by 1. So the x change would be an increase of 1. So that'd be a positive 1. Okay, so my slope of my data table would be negative 2 divided by 1, which is negative 2. Okay, the y-intercept of my data table is the y value across from x equals 0. So I need to find 0 on my x side of my data table. Uh-oh, whoopsies. You know what, we can do this. We just need to use the pattern. Okay, there is no 0 on my x side. So I'm just going to keep counting backwards. Okay, I'm going to follow the pattern. Okay, 5, 4, 3, 2. I'm going to stick a 1 up here. And then I'm going to stick a 0 up there. Okay, I'm just following the pattern because I want 0 to be right here. Okay, follow the pattern on the other side. 14, 16, 18. Do you see it's going up by 2s? Okay, 14, 16, 18, 20. Be 22 right here. Be 24 right there. So I had to do a little work, but the y value across from 0, if I followed the pattern, would be 24. So my y-intercept is 24. So now I have my equation. Y equals slope x plus y-intercept. Okay, the slope is negative 2. The y-intercept is 24. So my equation would be y equals negative 2x plus 24. Okay, guys, do the best you can on this. I didn't do a whole lot of examples or even this a big lesson in your notes because we're going to keep coming back to this in different ways. And also IXL, what you're going to be doing with this is an IXL lesson. It's very good at reinforcing this. I think you're going to catch on. Okay, so the slope. Slope of a data table, just find the change in your y values over the change in your x values. Okay, the y-intercept is the number across from x equals 0. And you may have to just kind of count backwards to figure out what that y-intercept is. Okay, let me know if you have questions, and I would be glad to help you.